So we have a property for inverse functions, and the property goes as such. So two functions are inverses of each other. So let's say, let f be a one-to-one function, and f inverse be the inverse of f. Okay, then if you compose the two functions, if I get f of f inverse of x is the same as f of f inverse of x, okay, and the second one is f inverse of f of x is the same as f of f inverse of f of x. Now we know this, but in case of inverse function, if these two functions are inverse of each other, then this will always come out to be x no matter what. Whether you do f o f inverse or whether you do f inverse o f, both of these will end up being x. Okay, so let's look at an example. So show that fx equals 2x plus 3 and gx equals x minus 3 over 2 are inverses of each other. Okay, so we want to check that these two are actually inverses of each other. So let's test our inverse function property. So I know that f o g of x, right, and g o f of x, right, so I have g o f of x, which is g of f of x, both of these should come out to be equal to x. So do they? Well, let's see. F of g of x, I'm going to plug in g of x, so this is going to give me f of x minus 3 over 2. Okay, what does x do? It multiplies it by 2 and then adds a 3. So this is going to be 2 times x minus 3 over 2 plus 3, which cancels this out, which gives me x minus 3 plus 3, which is x. So we see that f o g of x comes out to be x. Well, now let's take a look at g o f of x. So this is g of f of x, which is g of 2x plus 3. Okay, and so what does g do? Well, g first subtracts the 3 and then divides everything by 2. So I'm going to get 2x plus 3 minus 3 over 2. So that cancels off, which gives me 2x over 2, which is simply x. So we note that f o g of x is equal to x, and we also know that g o f of x is also equal to x. So we can verify that these two functions are actually inverses of each other.